Alright, so now we come on to like a really common type of question for surds. And it's rationalize the denominator. And what kind of, so there's two types of rationalize the denominator question. It's one where, you know, it doesn't really matter what the top is. But say you got something like this. Yeah, so the first type is where you just have like a surd on the bottom. No plus or minuses. You might have like two root 6 on the bottom. But there's only one term, you know, and terms just like how many things they are separated with by plus or minuses. So on the bottom it's just a surd, maybe it's surd times a number. Now there are harder ones as well. So a harder type would be literally having the same thing there, but then you've got plus something else. So you've got more than one term. Can you see? So this is the harder types, and this is the easier types. So in this video we're going to go over the easier types, but more importantly I'm going to tell you what it means to rationalize the denominator, tell you the thinking and the reasons why we do each step. And then once you get that, you'll see that the hard rationalize the denominators are straightforward. They're very, very straightforward. And by the way, these rationalize the denominator questions, these hard ones, are considered one of the most difficult questions in the whole syllabus. Not only are they A-star questions, but you know, next year, you know how they changed the syllabus, they're going to make, you know, there's not going to be like A-stars and like D's and B's and stuff like that. Instead, there's going to be like grade 1, grade 2, and like grade 9 is the highest. That's considered like the top half of what an A-star is now. These questions are considered grade 9. They're considered incredibly difficult. But what we're going to do is we're going to go through it step by step. And the reason why it's considered so difficult is no one teaches it in a way, you know, which I just think is logical. So, right, so let's kind of just jump straight into it. And let's kind of begin with, you know, let's start off with a question. So you'll get given something like this. And it will probably say something like simplify by rationalizing the denominator. I'll just call it RTD by now, you know. Simplify by rationalizing the denominator. Now, a lot of people are kind of taught how to do this, and they always said, oh, if you get a question like this, what you do is times top and bottom by root 5, which is correct, But do you see that it's just, you've just been told how to do it? And if you keep thinking like that, that's why the harder rationalized denominator questions are considered A-star questions, because then it's not the same logic doesn't follow on to that. But if you understand why you times top and bottom by 5, you'll find the next one's very, very easy. So anyway, let's first understand it. So the actual clue is in what the question is asking. It's saying rationalize the denominator. So here's what the question gives us. The question gives us a top, you know, essentially a fraction where the top number is a 4, i.e. the numerator is 4, and the bottom number, the denominator, is the square root of 5. And the problem is the denominator, because it's a square root, isn't rational. So right now, the denominator is irrational because it's a square root. Remember, all square roots except for square root of 1, 4, 9, 16, you know, the square roots, the square numbers, excuse me, are not rational. So that's the problem we have. So first things first, let's make sure we understand that. So our aim here is not to change this number. So right now, yeah, in your calculators, do 4 divided by root 5. And if you've got one of those new calculators, it'll actually tell you what the answer has to be once you finish the rationalized denominator question. But I care more about the number, so press that S to D button or something like that, whatever it is. And you'll find that the value of this is 1.7885 something, right? So the question isn't saying to change this number, it's actually saying simplify. So what it's saying is write this number in write this fraction in a different way. So it's the same number, but the bottom, the denominator, isn't a surd. So that's what I've written here. Look, rationalize means rational means not a surd. That's all you have to think about. You're just trying to make it not a surd. And that's the denominator, obviously. So here's what you do. Here's what I've written for method. Multiply top and bottom by the third, which makes the denominator a whole number. Another thing to understand, it doesn't really care what the numerator becomes. The whole point of this is simple. Just change this number so that the bottom, just becomes a whole number. More importantly, not a third. So here's the deal with this. There's only one number we can multiply this by. We're going to do a trick, by the way. This is the trick on how to change it, how to actually rationalize the denominator. So listen, we can't times this by 2 or add 1 or take away 3 because that will change this number. We can't change the number. We're just changing in a different way, in the same way that 2 over 4 is 3 over 6. That's all we're doing. Yeah, these are the same, but you can write them different. So here's the deal. What's the only number we can multiply this by so that the actual value of this whole thing doesn't change? Think about that. And the answer is 1. That's the only possibility there. So the next thing, but here's the thing, that's not very useful to us. But it is, because you can write 1 in loads of ways. So we could write it as 1 over 1. We could write it as 3 over 3. 517 over 517. But here's also the thing, we can also write it as a third over a third. So we write it over root 2 over root 2. Right over 316 over 316. So here's the thing, what we do is we be very smart about our choice, and this is what we do. We pick root 5 over root 5. And the reason is simple. So now that we're doing, we're just doing a fraction times a fraction. Now see what happens when we decide to times top and bottom by root 5, which by the way, don't forget the value of this, because it's root 5 over root 5, is 1. So listen, the tops, obviously when we're multiplying fractions, the top is just going to be 4 times root 5, which is 4 root 5. But now look at this, on the bottom you're going to have root 5 times root 5. Now what is that? That's 5. Okay, now remember the question. And by the way, put this into your calculator, see what you get. Yeah, exactly the same number. Yeah, we haven't changed this along the way, because all we did was we multiplied it by a special version of 1. That's the key thing here. We used a special version of 1. We didn't change the number. And that's it. The question's done. All it wanted us to do was rationalize the denominator. I know we've got a third on the top now, but you might be like, how's that any better? It doesn't matter. The question just asked us to rationalize the denominator. That's done. Yeah, we don't really care what mess is on the top, as long as this is a lovely number like that. And literally, that's it. It's straightforward as that. So now I'm just going to go through a few other examples, and that's really all there is to it. So alright, so let's go to another one. Let's go to 7 over root 6. Okay, well we've got to times, the only number we can times it by is 1. But we've got to be smart. We're like, what are we going to times top and bottom by? Well, here's the deal. All we care is the bottom. So we're going to, because we know that root 6 times root 6 is going to give us 6. And obviously this has the value of 1. So we multiply top and bottom by root 6. So this one just becomes 7 root 6 over 6. Stick in the calculator. The value of that is exactly the same as that. And that's it. That's literally it. So I'll run you through a few more. But you see, nothing changes. And it's this thinking which, when we take it through to the harder ones, obviously it doesn't work exactly the same, but it's easy. Alright? So there's one other thing as well. Look, it wants it simplified down as much as possible, right? So, let's do 6 root 3. So you guys go do it. So I'll pause it, do it. Alright. So you should times top and bottom by root 3. So that the top will give you 6 root 3 over 3. Now, we can actually keep simplifying this. So basically, at this stage, you've rationalized the denominator. But, say like you solved a question and you got it down to, 5 over 10. You'd still want to kind of simplify this up, right? And here's the deal. So you've got to remember how to simplify tops and bottoms of fractions. There's a video I made about that as well. You've got to rewrite the top and bottom as a chain of things multiplying. rewrite the top and bottom as a chain of things multiplying. And if there's the same thing on the top and bottom, cancel it. So, don't know if you guys can see, obviously you can rewrite 3 as 3 times 1. I'm going to rewrite the top as this. You see? Chain of things multiplying. Do you see how there's a common 3? Yeah? So your answer, so basically this simplifies to that. 2 root 3. Does that make sense? In a way you can just kind of see it like that as well, because here's the deal as well, here's another way you could see it. Imagine I asked you to multiply this stuff together. Can you see, using fractions, that will just literally become what we have. So this is the same as that, except we know that 6 over 3 is 2. That's just root 3. So that's how you cancel this down. Again, if that doesn't make sense to you, go watch the how to cancel anything on top and bottom of a fraction. Okay, that's all there is to this. It's a very, very straightforward question, these rationalized denominators. Let's do one more. Let's do 1 over 7 root 7. Now this one's interesting actually. Because here's the deal, like when people are just taught this without really understanding why you have to do it, and they're just told, oh, times top and bottom by whatever's in the bottom. You will go into this and you do, this is a very common thing. People would times top and bottom by 7 root 7. Now this will work, but let me tell you why it's not the best idea. So look, the top's going to become 7 root 7. Now let's think of what the bottom becomes. So you've got 7 times root 7, which is that, times another 7 times root 7, which is this. So we can reshuffle the order. So we got 7 times root 7 times root 7, right? So this is 49. And root 7 times root 7 is 7. So you get the bottom to be 49 times 7. Just pull my calculator out. Becomes 343. Okay. Now I can cancel this. So I rewrite the top and bottom as a chain of stuff multiplying, which is just that. Now this can actually be written as, I don't know, there's a few things, but you can take 7 out of it. Again, not super easy to see, but you know, I mean, we can break that down further. I could have wrote this as 7 times 7 times 7, but it's a chain of things multiplying, right? I'm just trying to cancel this thing anyway. So look, cancel it up. And that's your final answer, root 7 over 49. But here's the problem. You do it, that's not the way I recommend you do it, because you're not thinking in the right way. Because that's what you do if you follow a rule. You like, oh, I just multiply it top and bottom by whatever's on the bottom. No, you want to remember this. The question's asking, just do what, multiply top and bottom. Obviously they have to be the same because you can't change the number. You've got to times it by 1. You've got to keep this number the same. By whatever you need to make this bottom not a third. So here's the thing, you only need root 7. Because think about this. The bottom, you've already got 7 times root 7. Now you times it by root 7. So here's the thing, look, that thing becomes 7. And you already got 7. So you jump straight to over 49. So that's a much smarter way of thinking about it. A much, much smarter way. So yeah, I mean you can do it this way, but it just involves more work. Whereas this way is much quicker. You don't have to deal with having to cancel 7 over 3, 4, 3 and stuff like that. It's a much smarter way. This is where you're actually using your head. So yeah, let's give one more example of that as well. Let's go for this. So we've got 10 over, go for, what should we go for? No, let's go for 3 root 5, that's 5. Alright, so remember, be smart here. We just want whatever on the bottom, so 3 times root 5. What do we need to multiply this by to get to a whole number? Well, you can see if we just add on an x, well let me do that in a different colour as well so it's clear for you. You know, all I have to do is add on an extra root 5, because then that will become a 5, right? Then I'll have a 3 here, and that'll give me 15 on the bottom. Simple, so that's what I'm going to do. Root 5, top becomes 10 root 5, and as you've seen, bottom becomes 15. Now remember, cancel top and bottom at the end if you can. And all there is really to this, I mean I know I went long kind of rewriting this top and bottom, but can you see if 5 goes into both of these once you get comfy with that? So it means I can rewrite the top as this. I can rewrite the bottom as this. Cancel, cancel. So your final answer is 2 root 5 over 3. And that's it, guys. That's literally it to any of these questions. Not really much more to say than that. Obviously, I'll be going over more examples, because at the final video I'm going to go over in CERT is just God knows how many examples of different types of questions. But that's it, all right? Hopefully it makes sense to you. So I'll cover it again. Rationalize the denominator. They'll give you something like this. Yeah, the problem with the question is, at the moment, the denominator has a surd. In other words, denominator is irrational. The question is saying, look, it's saying, don't change this number, man. Don't change it. It's saying, as in, don't change the number of it, so don't times it by 2. But it goes, rewrite it in a different way, so that this bottom bit doesn't have a surd, aka it becomes rational. So that's what we do. We just times top and bottom, yeah? And it has to, top and bottom have to be the same, because you're timesing it by 1, yeah? But you times top and bottom, but purely all you care about is this. You just want this multiplication, whatever that is, times that, to give you just a whole number where there's no surd, and that's where you're done. The last thing to do as well, just make sure that there's nothing on top and bottom which could cancel. If there is, cancel it. That's it. It makes sense. It's very logical. That's it. Alright, so we'll go to the harder types of rationalize the denominator, and that's it.